Okay, we're going to pick up where we left off Friday, and where we left off is we were talking about transformation. So you should already have this written in your notes. First of all, a transformation affects the appearance of a parent graph. That's what a transformation is. We have a rigid transformation, which changes only the position of the graph, so that means it moves it. And then we have a non-rigid transformation, which distorts the shape of the graph. And so if you look here, we're going to be looking at vertical and horizontal translations first of all. So a vertical translation, so this is taken from your book, basically states that we're going to translate this graph k units upward when k is greater than 0. So whatever value k is going to be how you shift it. If k is positive, you shift it up. If k is negative, you shift it down. Okay. Now here on the x translation, notice it says f of x minus h. This is going to be the opposite. So whatever is in the parentheses here, you're going to do the opposite. Oops, let's try and circle that one a little better. Actually, I'll highlight it. Okay, whatever's in the parentheses here, you're going to do the opposite of. So if it's minus h, you're going to do a shift of plus h. If it's plus, you're going to do a shift of the negative. And so that's not going to probably make a whole lot of sense now until we look at an example. So first of all, we are starting with the parent graph, the absolute value of x. You know the absolute value of x is a v. Okay, and now what this states is that I have g of x equals the absolute value of x plus 4. And so in looking at this, I see I've got a change right here. This is a shift. This in this case, it will be a shift up or down. And I need to determine, is it going to be up or down? And it's going to be up, how many? 4, because this one is actually whatever it says you're going to do. And so in this case, what you're going to do is you're just going to go ahead and take the graph and you're going to move it up 4 spaces. And so that is what your new graph will look like. Now let's look at the next one. This next one, if you notice, there's a change in the graph, and this is the change, plus 3. And so what type of shift is this going to be? This one's going to be a left or right.
I think it's
Reason being, because it's inside the absolute value. This one wasn't. This one was outside. So if it's outside, it's going to be up or down. If it's inside, it's going to be left or right. Now this is the thing. If it's left or right, in this case, it's always the opposite. So since this says a plus 3, you're going to do a shift the opposite. So you're going to go a negative 3. And so in this case, what your graph is going to look like is it's going to look like that. So the original parent function was blue, and then you've done a change in the purple, and you've done a change in the pink. Okay. Let's look at the next one. All right, so now notice this one. From the original absolute value of x, you have 2 changes. You have the first change, which is right here. You have the second change, which is right here. So let's go ahead and do that first change. When you see x minus 2, what's that a shift?
Right. Shift to the right.
That is a shift to the right 2. What is the shift to negative 1? Down 1. So that means what I'm going to do with my parent graph, I'm going to start and I'm going to go to the right 2, and then I'm going to go down 1, and that is what the new graph will look like. So it's just a matter of looking at the equation, recognizing what you do, and then performing the translation. Now, granted, I know some of you can just type these in on your calculators and go from there. The problem is, come test time, I'm going to restrict your calculator use on these. So, anyway, let's look at this next one. So we've done the translations, which are left and right, up and down shifts. Now what we're going to do is we're going to look at how you reflect. Now, first of all, if you look at this first one, it says reflection in the coordinate axes. If you reflect it along the x, you're just going to negate the whole thing. Okay, so the whole thing will be negative. You reflect along the x. If you reflect it along the y, you just negate what's inside the parentheses. Okay, so if I look at this one, the first parent graph is f of x equals x squared. You already know that f of x equals x squared is going to be a parabola that opens up. So now this is what you're going to do. Describe to me what's different in the given graph versus the purple one. Yeah?
Nope, she doesn't have a question. It's a choking strategy. If you're choking, you put your left arm in the air.
Okay, so what's different from the purple one?
Katie just messed me up.
Sorry.
It's what?
It's reflecting off the edge.
Okay, so it's flipped, right?
And it's moved to the right.
It's flipped over the x, and then it's moved
Let's just say 2.
2.5.
It's like 2.5.
right
Just
2.5.
Ah.
So now, this is what you need to do, because otherwise than that, if you just have your equation, there's not a whole lot of credit I can give you. So first of all, I know my equation is going to be g of x equals. Okay. Now, I flip it over the x, so when I flip it over the x, that means I just negate the whole thing. Negative. And so now I need to figure out to move right. Okay?
Absolute.
To move right. And my original equation is x squared.
I got this.
What?
To move right, I'm going to do
X
this.
squared minus
2.
2.5.
Is that really it? Yes. Oh,
You have to do it backwards.
feels so good to get
You
this.
have to do it this way. You cannot write it this way. If you wrote it this way, because I know some of you are probably going to say, well, I could just do this. Okay, if you wrote it that way, that's actually going to be what?
Wrong.
This is going to be shifted how? It's going to be shifted up 2.5 instead of right 2.5. Okay, so let's look at the next one. Tell me what's happening with the next one.
It's a Y.
It's flipped,
Over X.
flipped over x again, and then what's it done? Moved up how many?
2.
Up 2. So this one's a little bit different than the problem we had before, because the problem we had before was given g of x equals negative the quantity x minus 2.5 squared. What do you think this one's going to look like?
Equals
Negative what?
2x. No, negative. 2x plus 2.
X squared plus 2.
Negative x squared plus 2.
Oh, Lord.
Okay. Remember, the up or down shifts are not affected with the x at all. The left or right are the ones that you modify the x. Okay, let's look at another one. Describe how the graphs of f of x equals 1 over x and g of x are related. So first of all, I can tell you right now that g of x looks something like, or actually f of x looks something like this. Now how do you know that? I quickly plugged in the numbers -1, I plugged in the number 1, plugged in the number 2. That is what 1 over x looks like. So compare that to the one that's given in blue. What have we done? You flipped over x, that'll work. You flipped over the x, what else have you done? Nope.
It's hard to
Flipped
do
over the
this.
Y.
Oh, it's moved down.
Down how many?
2.
2. Now this is how you know. You've got an asymptote here at 0, right? An invisible boundary. If I look at this graph, where's there's an invisible boundary? In the blue, it looks like there's one at -2. So really what you've done is you've moved that 0 down 2 spaces. Okay, so that's how you know it's moved down 2. So it's flipped over x. So to be flipped over x, that means I'm going to negate the whole thing. So I've just got negative. Okay. Now since I moved it down, do I do anything to the x? No, so it's just -1 over x. How do I do a down 2 shift? -2. So let's look at the next one. What have you done on that one? Flipped over the x again. So I flipped it over the x. And I've done what? Moved it. Left how many? 4. So let's see, why is it 4? Because let me see, 1, 2, 3, 4 is where the invisible boundary is that it doesn't touch. So now I've got g of x equals. I'm going to just once again negate the whole thing. How do I do a left move of 4? In parentheses. X plus 4. Remember, the x's are the opposite. Okay, so I want to move left 4, so I'm going to do the opposite of that, and I'm going to add 4. Now this probably right now is probably a little foggy. It's not making complete sense yet. Okay, we're going to spend some time on this though and try to get that down. So now the very last thing we're going to look at are some vertical dilations and horizontal dilations. Basically, think of it this way. If you multiply by a number bigger than 1, it's going to make it steeper. It's going to get bigger faster. And that's what's happening here. It's getting big fast. Okay? If you multiply by something from 0 to 1, it's gonna take longer to grow. Okay, if you take half of something, it's gonna take longer to grow, and so that's why this one's taking longer to grow. So we've kind of elongated it. And so, the very last thing we're gonna do is we're gonna look at how you graph this piecewise function. And I'm gonna show you some techniques here. So let's look at the first one here. It says g of x equals x minus 5 if x is less than or equal to 0. So these are the three numbers I'm gonna plug in. I'm gonna start with 0, and then I'm gonna plug in -1 and -2. So if I plug in 0 first, what do I get? -5. So 0, -5, I've got a closed dot. Can somebody tell me why I've used a closed dot? Because it's equal to, right there. Now I'm going to plug -1 in. When I plug -1 in, what do you get? -6. When I plug -2 in, what do you get? -7. So the left part of this graph is going to look like that. So essentially what I've done is I've made a T-chart, which is something you used to do in algebra, and this is all I've done. That's all I've done when I pick those three values. Now what I'm going to do is the same thing with this middle graph. The values I'm going to use, I'm going to use 0, 1, 2. Okay? Now, I always want to use my starting point and my ending point, so in this case 0 and 2. If this would have been from 0 to 4, you would have used 0 and 4 at a point in between. So at 0, what is x? 0. So I'm going to use an open circle here because it's already included below. At 1, what's it going to be? 1. Now for those who wondering, where are we getting that? 0 cubed is 0. 1 cubed is 1. What's 2 cubed? 8. Do I include that point? Why? Because it's equal to 2 right here. And this one is going to be part of the cubed graph, which is going to look like that. It's not a straight line since it's cubed. The very last one I'm going to do, can somebody tell me the three values you think I'm going to use here? 2, 3, and 4. So I'm going to start with 2. If I plug 2 in here, I get 2 over 2, which is what? 1. So I'm going to use an open circle there because I've already got a closed one up here. What about 3? 2/3. What about 4? 1/2. And so that one's going to look real similar to the one we just got done looking at. So it's going to look like this. Because 2 over x is real similar to the 1 over x, where we had an asymptote. So that's how you graph that piecewise function. So on your homework, you're going to have some various different ones we're going to look at. You're going to have a worksheet tomorrow over the same stuff with translations to try and get those down. Yes, sir?
For the last
Yeah.
thing, why is 2 included if it's not equal to?
Okay, the reason, you mean why do I even put an open circle here?
Yeah, or even include 2 if it's not.
Okay, this is the thing. What that does is that it says x is greater than 2, so that could be 2.000000001. So we need to know where does that start. That's why we use the open circle now. Does that answer?
Yeah.
Okay. Assignment then. There you go. 52 through 53, 2 through 30 to the evens, and number 40. Okay. You have the rest of the time to work. Like I said, we're going to spend another day on this, a worksheet tomorrow.